Okay, so last time we started talking about how System 1 can push you around when you're thinking about numbers. What we'll talk about today, you can think of in terms of System 1, but we're going to think of it more like this. Even at the level of System 2, there are certain ways of thinking about numbers and probabilities in particular that we're just not very good at. And in order to think about probabilities correctly, we need to kind of relearn how we think about probabilities, how we think about numbers in these kinds of cases. So we're going to start with a very, very simple problem. And the problems will get more complex as we go along, but we're going to start with a very, very simple problem. So here's the simple problem. You have two people here. One tells the other. The one talking is, let's say, the experimenter, the scientist conducting an experiment to see how subjects will behave. And she says, 100 people have been given thumbnail descriptions. That means just like short little descriptions. 70 of them are lawyers and 30 of them are engineers. Here's one of those descriptions. Dick is a 30-year-old man. He's married with no children, a man of high ability and high motivation. He promises to be quite successful in his field. He is well liked by colleagues. So that's the description. He's 30, married with no children, high ability, high motivation, promises to be successful in his field, and he's well liked by colleagues. And then you ask, what are the odds that Dick is an engineer? And this person would reasonably say 50%. Why? Because that description doesn't really fit with lawyer versus engineer in any particular way. And with such neutral descriptions, most subjects just say that the probability that Dick is an engineer is 50%, and that's perfectly reasonable. But given the information that you had on the problem sheet that you had to fill out, if you put 50%, you weren't quite so reasonable. Why? Because in that information, it mentioned that 70 of the people in the sample, 70 of the people whose descriptions you were getting were one thing, were lawyers, and 30 of them were the other. 30 of them were engineers. Well, if 30 of them are engineers and the description doesn't push either way, then you should just say, well, the odds are 30% because 30% of them are engineers. Ignoring this kind of background information about the distribution of a characteristic like lawyer versus engineer in a population, ignoring that kind of information is called the base rate fallacy. And the reason it's called that is this background information is called a base rate, or sometimes called a background frequency. There's other labels that it can be given. But it's in the way of thinking about it that we'll end up adopting, it's called a prior probability. But for now, we'll just call it a base rate. Okay? So that's the first problem. Probably many of you got that right. Probably many of you put 30% as your answer. But there are at least several who will have put 50%. Okay. Now that's the easy kind of problem, but it sets the stage for thinking clearly about the more challenging kind of problem. And I'm going to leave this video very short, and we'll turn to the more challenging kind of problem in the next video. Before we get there, though, I want to mention one thing, which is that this kind of reasoning that I am imploring you to adopt, the way of thinking about probabilities that most people intuitively kind of don't do, but you can learn to do, and which improves your assignment of probabilities, is called Bayesian. Because there's a theorem authored originally, well, not really originally, but attributed to a guy named Reverend Thomas Bayes, so hence Bayesian. And it's a theorem of probability theory, and that theorem will come up at various points in the course, most saliently in the scientific reasoning portion of the course. Okay, we'll stop there.